days, many of the organizations that go for the cloud, because the data is massive. So I was talking with one of the hospitals CISO. He was saying that it won't be possible for us to store the data locally because the data is massive. And he was also saying that we are paying in crores for the cloud service, the data storage, whatever they are taking. And who will own the data? So one thing is sure, that data owner is that respective person. For example, if I say that I'm going, in case of the healthcare, I am the data owner. If I am the patient, I am the data owner. But it may be maintained by me or it may be maintained by someone. For an example, if it is e-healthcare data, see, I am the owner, but it is not maintained by me. It is maintained by the hospitals and they store in the cloud or whatever it may be. So it is maintained by the service provider. In certain cases, I may be keeping all my records. So where I will keep, it is my location, or I may store it in the cloud and then I will maintain it. So it's my record. But in case of the service provider, my record will be maintained by that service provider in their own location, or it may be in the third-party storage. So as we know that the data can be in any of the 3 states at any point of time, but we can say that, as I mentioned, that we can take any number of copies. That's why the double spending issue also comes. So the data can be in the transit as well as at rest also at the same time. When the data is in transit, there is no problem. We have the HTTPS protocol that ensures. However, the process and rest is always the issue. So when we are going to do the process, the processor is going to handle the data. And if the processors are compromised, so then it is possible they will get the data, whatever is there. So the data leakage can happen. So we have solution for that also we will discuss. It's not only with blockchain, by adding the cryptography mechanism into that. So finally, what we need for the data, there are applications. Normally we say that confidentiality, integrity, and availability, but there may be applications, or there are applications where we say that first I want availability is my important requirement. We can say that availability and integrity will be almost equal. After that only I go for the confidentiality. So in the e-health, we want confidentiality, that is the privacy, but before that availability is very important. So the challenges, as I said already, like one is the privacy is required for my data. So if my data is there, by chance also, if somebody come to know my data, he should not link that with my identity. So they should not link, or they should not be traceable. So these are my requirements for my data. And this can be ensured with either cryptography mechanism or the non-cryptography mechanism, where we will be doing the anonymization. And we want to ensure the security, that is, we can achieve the privacy by applying the security, that's the confidentiality. Also, we want to ensure availability of the data at all the time, because we know that availability is very important in various cases compared to the confidentiality of the data. So, and we need the integrity, the data should not be modified. So, and when we are going to handle the data, so we have to see that who is the owner, because owner is the one responsible for granting the permission. So, and those has to be recorded to whom he is giving permission, because this will help us in identifying that whether someone is accessing the data without the consent of the owner or not. And then also we want to log all those things, and it has to be audited maybe in regular interval or whenever it is needed, to find out any leakage or any unauthorized access happens on the data. So for the data, if you consider the threat model, so there are threat agents. So they may be insider and the outsider. So insider is referred as the organization which maintains the data. There will be an attacker who is present in the organization. That means he has the sufficient access to the data, and then he will perform or misbehave with the data. And the outsider who has to cross multiple boundaries and get into the organization, and then he has to modify or whatever he want to do on the data. So the threat model, if we see for the data, so we don't want any unauthorized access, unauthorized modification, and unauthorized creation of the record also. Because people may create the record. Let's assume the case. See, I'm taking as an example only. So now there are hospitals where, for an example, they have the government facility to take the treatment. And for that, the money will be sent by the government to the hospital. If the hospital is creating the record, that is a fake record, mentioning that so and so person has visited the hospital, and accordingly the record is created. So what happened? The hospital will be getting the advantage, and it may be created on some patient name, and that patient will get affected in future if he goes for any of the other treatment, because the doctors will be looking at the complete health records, and they may see that there was some record that contains some of the prescriptions. So these are the problems. And there is another one, that is the ransomware. So we know that these days ransomware is the major threat, because the data goes non-usable. So, and I can say one example, but this is again the contradictory. So because of the ransomware, there were deaths reported. The first one was in Germany, but again they are saying that it is because of some other reason. So it was like that GPS, the data was attacked by the ransomware, and the ambulance was unable to reach on time to the hospital. By meantime, the patient died. But as I said, that still it is not clear whether it is because of ransomware or not. But such kind of incidents can happen if the data is completely affected by the ransomware. And normally what happen, organization may pay and get the key to decrypt it, but as an individual we should not do it for two reasons. One is there is no guarantee that they will give the key, and the second, they may give some account. That account may be maintained by some cyber criminals, so where we will be targeted since we are transferring the money to that account. So that's why even if the ransomware happens, we have to think that whether we can go for paying it or we can apply a different mechanism. Even once we have experienced, and then we recovered the data, whatever was infected by the ransomware. So now what blockchain can do for the challenges, whatever we were discussing. And we all know that the blockchain is the decentralized database, and every party, whoever is taking part in that particular application, will be having the exact copy, but with some delay in having the exact copy. And if if anybody is going to change any of the data, it will not be possible. So instead of saying that it will not be possible, the chance of modification is very, very less in the blockchain, because we are going to ensure that majority as well as that the computational power will not be there. That's why we say that the chance is very, very less. If they have that majority, if the attacker side has the majority, then they can modify the data. So here they cannot modify the data since the data are cryptographically connected. So we use the cryptography hash and connect it. So the key features of the blockchain, if we see, the first thing is immutability. So that's, as I said, that blockchain by default refers to decentralization, and also it gives the immutability. So the data, whatever we post on the blockchain, it is not possible to modify. So rather I can say again that the chance of modification is very, very less. So once it is posted, so the chance is very less to modify. So we can ensure that whatever data, or guarantee that whatever the data we are going to have in the blockchain, and if we use that, so that nobody has touched it. So the data integrity is ensured, and it provides the transparency that anybody can verify. So the transparency we can see in two aspects. One is the actual data can be seen by any public, or only the validation can be done by the public. See, for example, if we see in Bitcoin or Ethereum, so anybody can see who is making the transaction. Who is making the transaction means that which address is making the transaction to which address, because the address is pseudo-anonymous. We do not know the identity of the person. But we know that from this address to this address, so and so this much of coin is moving. So that's one transparency. In another transparency, what they do is they don't leak out who is making the transaction to whom, but it's possible that we can validate that data. Any public can validate whether the transaction is correct or not. And here there is no single point of failure, because even if one person goes off, there are other persons to carry out. Let me give an example of the Bitcoin. Even if the entire world comes and say that the government say that no, we will not use Bitcoin, there is no guarantee that Bitcoin is killed, because there may be the dark web which will be running the Bitcoin. So it will always say that there is no single point of failure. Even the massive number of people come together, then it is very complex to kill that particular application if it is worldwide. So until unless everybody comes and accept that, so now we will not use, then only that application will be considered as killed. Otherwise, it will be live. Maybe we notice or we don't notice. And here we don't need to have any assumption of the trust. That is not required. By default, the blockchain provides, and it provides the cryptography security to ensure that only the specific owner is making the transaction. Also, we have the smart contract. So blockchain 1.0, when the Bitcoin was there, so they don't have the smart contract, they work on it, but the application cannot be built. So they have the script for validation of the transaction and validation of the signature, but we cannot build the decentralized application. So in blockchain 2.0, Ethereum has given that provision for building the decentralized application on top of it. And then Hyperledger had come, so where we can have our own blockchain for having running our own application. But if we see that either it may be the Bitcoin or Ethereum or the Hyperledger, so those are also like they were using the sequential data structure. But in case the IOTA, if we see, they are going for the non-linear data structure. So they claim that they can do the task very fast, but still there are some issues that I will discuss where we fail. I will give an example for that. So whatever the transactions that are happening in any of the blockchain implementation per second, that won't be sufficient for one of our applications. So the blockchain gives all these features, but still it cannot ensure availability. So as I said that if you are going for, let's say, the Bitcoin, all the transactions are present. That is, the data is part of the blockchain itself. So similarly, the Ethereum. But if I go and build the blockchain for e-health, so I cannot have the e-health data on the blockchain because its e-health data is massive. So I have to keep it in some third-party storage. Only the metadata I will keep in the cloud, in the blockchain. So in that case, the availability is not ensured. So we can use that metadata to ensure the integrity, but the availability cannot be ensured if the data is stored offline. That means whatever I am referring to, cloud or IPFS or whatever it may be. So we need to have multiple copies so that we can ensure the availability. Even if there is a ransomware impact on any one of the machines, so the other machines can provide the data. And confidentiality also, the blockchain by default does not give. So they use the zero knowledge proof and all. That's for the transactions. However, our data, what we are storing, that will be on the offline. So we need the cryptography mechanism to secure that. So we can ensure with the help of blockchain that unauthorized data access does not happen, unauthorized data modification and unauthorized creation of records. So we can ensure that with the help of blockchain, this cannot be done. However, regarding the ransomware effect on the availability perspective, so as I said that we need to have multiple copies. But if you are going to have the data in the blockchain itself, so blockchain itself ensures the availability even in case of the ransomware attack. So the use cases of blockchain in India, if we see, there are different multiple use cases, but I go for very few. So first, let's take the land record. So we know that land record management system is one of the problematic one because there is possibility of manipulating the records. and the properties. So we notice in various cases. So earlier it was more, at least now it is minimized because of the digitization, but still it has to be resolved. And the major problem comes, see, initially what happened before the digitization, everything was on paper, people can do whatever they want. So later we bring it to the digitization, but the problem is the centralized database. So it will be with that particular government entity, and they are vulnerable for tampering. So they, in the sense that database is vulnerable for tampering, it may be because the compromise of the insider or the attack may come from the outside, and also it lack of transparency. But if we are going to use blockchain for this particular application, for example, Andhra Pradesh, I think the Telangana government also, they have taken as a pilot project of this, and they have implemented in certain districts. So even the development was done by IIT Kanpur, and they have also done the pilot project on the land record management system. So if we are going to have the land record management system on the blockchain, so blockchain ensures the immutability, and it won't allow anybody to modify or change the property to anyone's name, because it will be centralized and it's not possible for someone to modify just on his or her own. And since it's in the blockchain, people can use it for verification, so the transparency will be ensured. And next is the citizen identity. So we know that, for example, the mark sheets and all we are having in the DigiLocker these days. So there also we can apply the blockchain. So we can ensure that, so who can access and up to what time he can access as a owner of that record. So I can control that what, when, and where when the data has to be accessed. So we can use the self-sovereign identity with the help of the blockchain to have the control with that individual person, so he can decide. Also we can use the blockchain in the banking and the finance sector. For example, the KYC, and what problem we are facing if we are having multiple banks accounts in multiple banks, so we have to submit the KYC in all the banks. So if we are going for the blockchain and the banks will take part of it, so then we can minimize that, and also we can ensure that nobody can tamper it. And the healthcare, so here we have done the work and we face a lot of challenges, and there are a lot of limitations in implementing the e-healthcare. Not so we can use the blockchain, but blockchain can work up to certain limit. After that, when it comes to the complete privacy, so we need more add-ons with the blockchain to ensure it. So in the healthcare, we can keep the patient's record and with the access control. So the patient's record will be on the third-party storage. So the metadata and the access control, everything we can have in the blockchain. And the education and employment. So IIT Kanpur has developed the model where the certificates were issued through the blockchain. So using the self-sovereign identity, they issue the certificate for the participants of the program and all. So the same thing can be done not only for that particular education deployment, or we can also consider that employment. For example, this employee provident fund records also. So for these are some of the use cases where the blockchain can be used, but there are other use cases also. For example, that steel industry, even I have seen that in some of the organizations, the payslip, that also they are keeping it in the blockchain so that anybody can verify, because people, what they do is they we can say that they create the payslip, because accordingly they can get the loan or other benefits. So those can be avoided or completely, it can be mitigated by using the blockchain. So now the major issue comes. So when we are going to use blockchain for the data, So as I was discussing till now. So the first question comes, who will run the blockchain environment? Because even if we take healthcare, everybody will be, let us say that they will be the participants. So I can give an example. We have the Bitcoin. So in Bitcoin, some people may be having the coins and they don't do any activity other than making the transaction. So that also they may not do directly, they will do through some exchange. And there are nodes who will be doing or contributing to the liveness of the Bitcoin. That is the person, the node that will do mining, and they do the validation of the transaction as well as the creation of the blocks or the validation of the blocks. So I am referring here, who will run means the people, those who actively participate in the blockchain for its growth and the liveness. So if we take any of the applications, for an example, if I am going for e-health record management system, if one hospital is planning to go to use the blockchain, who will run that blockchain nodes? So in that case, it may be only that particular hospital is going to run. If that is going to run, only that hospital. So that is similar to the centralized database. We don't have the decentralization there. So the first challenge comes there. Second is the participating nodes. So it's not that the person who will be running the blockchain for its liveness and the node, that is the client who is coming to participate, they should also know how to work with it. See, the Bitcoin, we know that who will go, the person who is having the knowledge, they will go. But if you are going to implement e-health for the patients, so we know that in rural areas, people in villages, we know that people will not be having any idea about how to use the phones also. So this will be the major challenge. And next is the underlying blockchain. So we may run our decentralized application. For an example, I am running my decentralized application on top of Ethereum. So when I am going to run on top of Ethereum, what is going to happen? That means the security of the Ethereum is more important for me in addition to what I am going to build. That is for my decentralized application, which is the smart contract. And everything, if Ethereum will also go down. So what can be done is that MIT has come up with the concept of unified blockchain framework. So I'm not sure that whether it is completed or not. So they are in the development. So they are creating the unified blockchain framework through CDAC. So now it's for our country, and we can build on top of it whatever application we want to build. So we can have our decentralized application. So what I can understand or assume that, so this unified blockchain framework will be answering the first and the last, the third point of this. So who will run? Because when the government is going to bring this unified blockchain framework, and that will include so many entities across the country. So we will be having sufficient number of nodes that will be running the blockchain from framework or the blockchain application. So we ensure that it is really decentralized. And there is no underlying blockchain. So underlying blockchain here, I mean to say that we don't need the Ethereum. On top of it, I will build my application. So unified blockchain framework is given by the government. I will build on top of it. So I don't need to worry about the Ethereum implementation. Definitely, I should worry about the unified blockchain framework security. But so they may not go down at any time. So we can use the unified blockchain framework to develop our application so that we can minimize the risk that are involved in the blockchain implementation for any of the applications. So as I already discussed, the other issues that present with the blockchain when we are going to utilize blockchain for any of the applications. So one is the storage constraint and the scalability. I mentioned that already, that we have so many blockchain implementation, but you know that how many transactions that happen in UPI every second. It is very high, and we cannot map any of the blockchain implementation. Say it may be Ethereum, Bitcoin, or whatever. Even we use Hyperledger also, because Hyperledger claims that can perform more transactions per second when compared to Ethereum and Bitcoin. So those cannot map with our UPI. So the scalability is the major challenge when we are going to use blockchain in certain applications. And also the interoperability is the issue. So we will be having difficulties in integrating with the legacy systems and the regulatory. So there are cases for the cryptocurrency, we have a certain framework. However, for building the decentralized application, there is no, as per my knowledge, so no proper framework or the security requirements that were introduced. And the next problem is the data privacy. So this one I will discuss in the next slide because it is related to DPDP Act. And then energy consumption. So as I said that if you are going for the blockchain implementation, which is based on the proof of work, then only we have this issue. If you are going for permissioned blockchain, so it is not a problem. So we can say that this is not an issue. And the very important thing is, as I have mentioned previously also, we keep the metadata in the blockchain, actual data in some other place. It may be the IPFS or it may be on the cloud. So when we are going to have like that, that means there is an integration between the blockchain and the IPFS. For an example, let's say I'm going for IPFS one. So if any failure happens on any one of the side, the data cannot be used. So both has to be live always. And another important thing is, if somebody put some metadata, but they didn't store the actual data in the cloud, and because see, as a end user, we can see various things. Everything is proper, all the data are stored. But at the implementation, so we have to consider the efficiency, that is the computational complexity, storage complexity, all those things to be considered. So in our model, what we have done is, we considered Ethereum, and in the Ethereum, the last block will be having the metadata to access the patient record, which is stored in the IPFS. So when we have to access the record, so the metadata is getting used to access. That is the index to access the data from the IPFS. If somebody puts the metadata in the blockchain and he doesn't upload the data in the IPFS, and the patient comes to read the data from the metadata from the blockchain, and he used that for indexing, he cannot access the data. And according to our model, everything, no data will be accessed from the latest to the zero. That is the first visit he has done to the hospital. So because we want to ensure the efficiency, but the drawback is this. However, we have given the solution for that. But I want to say that if you are going for two different environment, so we have to ensure that interoperability is proper. So integration is proper rather than interoperability. We can say that integration should be made very well. It should be efficient as well as it should be very secure. So we have the DPA Act that was introduced in 2023, and we can expect that now anytime it will come for implementation. So it says that any data can be accessed based on the consent. And if somebody says that, no, I don't give the data to you, I take the granted permission, I want to revoke, so then they can do revoke, the data has to be deleted. And then also the act says that you should not collect more information, whatever is necessary, only that has to be collected. So this is what the act says, but there are so many other things that we will not go in detail. But the challenge is when we are going to use the blockchain, what is going to happen is we are going for immutability. So when we talk about the immutability, the data cannot be modified. Also, we say that data cannot be deleted. But we have one requirement, which is right to erasure. So if the person want to erase the data, he should be in position. But we have that problem in the blockchain. So it should be immutable. There are concepts like redactable blockchain. So that says that if somebody uploads the data, which is found later that the data is wrong. So then they can go for modifying it with the help of the redactable blockchain. But in this case, we are going to, again, we can use the redactable blockchain and then we can remove that data. But still, when we go for redactable, then everybody will take advantage of modifying the data. And even, let's say, when we are going for e-governance, so some data is put and then we want to, maybe by mistake it was uploaded and we want to modify it. So in that case, people can use the redactable blockchain and then the redactable concept, and then they can modify it. So one side, it is going to give the facility for the erasure or modification of the data legally, but another side, it is bringing the loophole also. So we have to consider that let the data be there, but if you want to modify the data which is uploaded incorrectly, you in the later blocks you can change it. But in case of this DPDP Act, so we want that the data should be erased. So the better option is we keep the data offline and then we can erase it there, but the metadata will be present in the blockchain, which is not going to give any impact. So this is the solution we have when we are going for the blockchain to use the data. At the same time, we will be complying with the DPDP Act. And also, one side we talk about the decentralization, but here we need to have the identifying controller, but the same can be applied. So for example, in the DigiLocker, what I can assume, so the DigiLocker is maintained by an entity, and that particular entity can have the control, but that control will be maintained at the blockchain. So the user can give the permission and that will be recorded in the blockchain, who can access the data at what time, and he can roll back the permission also. So according to that, the centralized controller, that is the identifying controller, can give the access to the data, whatever is there in the DigiLocker. But again, we have to see that what about that identifying controller? Will it, that becomes again the centralized, or we need the decentralization there also? So the solution is like, as I said, one is we can go for the off-chain storage, and the metadata like hashes or the polynomial commitments we can have in the blockchain for verifying it. So these days we see that most of the implementations are now going for the zero knowledge proofs. So they use ZK snark or ZK star to, they have the commitments. Maybe it's the polynomial commitment or other commitments. So they prove that the transactions are valid or the set of the transactions are valid without disclosing the transactions. Also, we can go for the homomorphic encryption. That is the fully homomorphic encryption. As I said that when the data goes for the process, so we have to decrypt the data if it is encrypted. But when we are going to use the homomorphic encryption, we can perform the operation on the encrypted data itself. And then as per the property of the homomorphic encryption, we can perform the operations on the encrypted data that is equal to performing the operation on the plain data. And we can have the permission blockchain with access control. So this allows us to use blockchain for securing the data as well as complying to the data privacy laws, that is the DPDP Act. But we have to explore more that whether any of the places that metadata will be misused, or it can be also going to leak any data, that should also be considered. So the one overhead, so maybe I have time. So the overhead analysis I want to discuss. This is what we have done in our research. What happened is people go for implementing the blockchain for the applications. But when we are bringing the blockchain, we can understand the overhead of it. One is the computational storage and the network overhead also, because if there are n number of nodes, all of them has to share the transactions as well as the blocks. So which will be the overhead for the particular application. So, and why we are going for blockchain for that application? Because blockchain has various key features, and because of that, we can secure the data. So that's why we go for the application. But at the same time, we have to make sure that the application should not be burdened by the blockchain implementation. So we have done the overhead analysis. So we considered Ethereum and then done the analysis. So these are the various parameters. So it was done long back. So by that time, whatever the Ethereum size that was taken. So for a node, considering all the blocks from the Genesis block to till that time, whatever the block size that we have considered, that is 667.10 GB. And we were using our own mechanism. We implemented our own model for that. But anyway, those are not required in this case. So what we have done is we just want to show how much overhead that blockchain is going to take. So we considered 4 models. One is like the hospital, it's considering the e-health. Hospital keeps the e-health record of the patient in the hospital server in plain format. Second scenario, we consider it is going to store in the encrypted format and keep it. And the third scenario, it encrypt and keep it in its storage as well as in the cloud. And in the fourth one, we considered that we are going to use the blockchain for the e-health record. So record will be, the actual record will be encrypted and stored either in the cloud or an IPFS and the metadata in the blockchain. So we want to do the analysis on that. So these 4 are the models A, B, C and D. So we measured that what is the hashing time and the encryption time. So that remains same for all. But for the first model, it is not required because it is going to be stored in the plain format in the local. The second model encrypted and stored in the local. So that's why for further analysis, A and B, we have not considered. So this one is, so when we are having the blockchain, we have to, for example, we considered the Ethereum, and in the Ethereum, we have to perform 2 operations. One is the read operation and the write operation. So read operation in the sense that we will access the data, whatever is there in the blockchain. And the another, in case of write operation, I will put my transaction and the transaction will be validated and then the state will get changed. So that is the variable will be changed according to the transaction. So the access is the read one, and the blockchain validation time here referring to the write. So in case of the Ethereum, so it was taking 2.2 millisecond in case of access time, but for the transaction validation and all, it was taking 16.5. And the blockchain size we have considered overall, that is 667.1 GB. And if the data is locally stored, we were accessing what is the time it was taking, that is 46.5 millisecond. And if it is from IPFS, this much, and if it is from cloud, it is this much. So actually, when we have done this implementation, the IPFS was at the early stage. So that's why we can see that IPFS takes more time compared to cloud. But now if we go, it is possible IPFS can, the access time of IPFS will be lesser than the cloud also. So the analysis, what we have done is, in the storage space, for the storage, if we go for the storing only the health data, which is of 2.5 GB, but in case of the blockchain based, so in the blockchain based, we considered metadata in the blockchain and the actual data in the cloud or IPFS. So the overhead, if we see, that is 667, that is the additional, too much overhead is there in case of storage. But in case of access time, so because both the applications are going to use cloud, so there is not much. And the other one is not going to use IPFS, it will be using the cloud. So that's why in the overhead I have given as 204, otherwise it will be same in both the cases. And if it is local storage, there is no overhead in both the scenarios. And because if you see in the blockchain, the data has to be shared among all the nodes. So if you see overall, that is the metadata, that is the transactions and the blocks. So that needs 20 Gbps. The actual, let's say the metadata will be 20 Gbps in case of the cloud. But in case we are going for the blockchain, so we need additional 3 Mbps, nothing more than that. So if we see that only the 3 Mbps additional, and we know that these days 3 Mbps is not much. So overall, if you see, this overhead is negligible. this overhead is also not applicable, because whatever both the models will be using, that will be applied. So the only problem is on the storage. So we need a lot of storage. So what we have done is we have proposed a mechanism where we can be deleting the blocks. As I said in the very beginning, that in our model also we say that let us delete the block, but we want to ensure that the data, whatever is there, that should not be completely deleted. So it may be possible, let's consider the case. We are making the chain of activities. So if we are having the last value in the chain, or last but one or last but two, those are sufficient. So in that case, we are considering like we can lose the initial data. But if let us say that in the chain, the latest data is in the block, which is very old. And if you are going to delete, then we will be losing the data to access that metadata to access the data from the actual health record from the cloud or IPFS. So we suggest that let's move it to the front, that is in the forthcoming blocks. And what this figure shows is, now we consider that 5 GB is very less, but let's consider that the threshold we have drawn, that a device is having 5 GB of storage. And if I go for Ethereum full node, which stores both block header as well as the data part. So in that case, the 5 GB node cannot survive more than 2 weeks. After 2 weeks, the storage will be filled. So it cannot take participation. But if I go for, let's say, that light Ethereum subprotocol, where the nodes will store only the block header, then it can go up to 234 blocks. So after, 234 weeks. After 234 weeks, it cannot sustain. So then there are many models, and we have also proposed our model like FSET hash, ISET hash. These are our models. So in that we say like, given we are going more than this week, our model will help in surviving. That is, the node which is having 5 GB storage can survive for very long time. Even in one of our model, that is the finite set hash. So the 5 GB is sufficient for going for very long period of time. So there is no requirement of increasing the storage. But you can see that the comparison says 6598 weeks, then 11,300 weeks. This is too much. So it is beyond the, we can say, the lifetime of the device. So if somebody may pose the question that, so you are proposing the model which will go for a long time, by that time it may be possible the device will not be there. So then why should you care? Because when the next device comes, it may come with more storage. But we have to see the environmental effect also. So normally what I used to say when there is a storage overhead, even for this, I used to say storage, see, like the Moore's law, if we see the cost of the storage device. So long back, it was like too costly, for example, the pen drive. And now the cost is coming down. So if we see, I have experienced the 256 MB pen drive in 2004 or 5 was 2,500 rupees, 256 MB pen drive. But now for the same, the 2,500 rupees, we can buy the pen drive in TBs. So we can see that with that, we can map and say that this overhead 667 overhead is not much after so many days. But the problem is, when I was talking with one of the hospital's CISO, as I already said, he said that no, this client cannot work because the storage requirement is very high. So whatever the law, that curve we are going to drive or draw, that will not be going to give any impact with this overhead. If the cost I'm saying, they say that it is huge storage they are going for and they are paying in crores. So even though I say that this overhead, because when the time goes, the cost of the storage comes down, but accordingly, the data size also increases. But the advantage here is we are not going to store the actual data in the blockchain. So we are going to store only the metadata. So this overhead and whatever I am talking about, that hospital will not be equalized. So if we use the blockchain also, this cannot be the overhead. So overall, what I want to conclude is blockchain brings the overhead for any of the applications, but it's not going to be burden for any of the applications. But only thing we have to make sure that we have to ensure that it is completely decentralized. There should not be very minimal number of nodes running the blockchain. That should be avoided. And another important thing is whenever we are going to build the application, that is the decentralized application, we should consider the threat model, that is the security requirement. Accordingly, we have to build our application. Otherwise, what will happen? There are always possibilities, because if we see in case of the digital, so if it is physical, for an example, the attacker has to physically come to our location and there will be very minimal visiting. But in case of the digital environment in cyberspace, they don't need to come. So from wherever they are, they can go for scanning the vulnerabilities and then they can perform the attack. So when we build our application, we have to ensure that we create the pattern, the threat model, and then we have to address that. So there may be vulnerability will leak. So that is like, it's not intentional or we are not aware, but we have to create the threat model. Accordingly, we have to build our application so that that application will survive against any of the cyber attacks that will be performed by any cyber criminals. So here I stop. So if any questions, then we will start interacting. I think you are mute.
Thank you, sir. Thank you for all the suggestions and the insights that you have shared. When you were talking, there were multiple questions that I was making a note of. And at the same time, there has been a question coming from different forum, different places where the this session is live. Before I take up the audience question, which is about multiple question, we'll be able to take about 2, 3. I have a few question which has been planned, and we want to know your perspective on these questions. The first question itself is, I would like you to throw your some light on the potential national security implication of a blockchain vulnerabilities, especially in critical sectors like health, finance, governance. What do you see that, sir?
The major vulnerability, or we can say the attack that can happen on this critical infrastructures. So the attacker's main target will be on the data. So that will be the ultimate aim of anyone. So in this case, what they can do is, because we are going to keep the metadata in the blockchain, actual data we are not going to keep in the blockchain. So it is possible that attacker will not go into the actual data. They focus on this metadata part. Okay, because that if I take my data and I am going to map, or the hash value I am going to map, if it mismatches, even though the data is maybe changed very little bit. So if the hash mismatches, then I have the doubt. Okay, so I will not use it. So their focus will be on that. So, and the next thing is, as I said in that e-health example, if we are going to store the metadata and the blockchain, the actual data in the cloud, if the data is created and stored and the metadata is not stored in the blockchain, or on the other way, in both the cases, the data will go unused. Not only that particular data, it's based on the implementation. So we have considered that various efficiency, we made the chain, and any data can be accessed from the latest data. That's what we have done. So if the latest data is not accessible, the entire data will not be accessible.
Got it,
So
sir.
this will be the major problem.
I have a link question. So blockchain by default is considered very secure. And we being a being a security company into blockchain space, we keep getting this question that why do we need a security in blockchain? Because it is immutable, it is most secure. I would like to listen to your perspective in 2 minutes. Why do we need security in blockchain? Blockchain is the most secure way of keeping a data or a ledger, correct?
Yes. So we consider in this aspect, let's say that you are going to build the application, which is the blockchain application, it's secure. But let's consider that you are the only one going to maintain it. So where the centralization comes. So the complete decentralization has gone. At the same time, the we talk about the immutability. That is also gone because you can do anything on that. So the decentralization has to be ensured. So the decentralization can be ensured when you have massive number of nodes participating. Then only the default security that is provided by blockchain can be ensured. And then you will be developing the smart contract, that is the DI. That might be having the vulnerability.
Correct,
Okay,
sir.
that can be exploited. So we cannot say that it's because of the blockchain vulnerability that impact is there, because when it is allowing the user to build the application on top of it, so it brings the attack or the vulnerability.
I
So
agree. Once anybody is building their own DApp, the developer is prone to do mistakes or vulnerability in writing their codes, and now those codes needs to be audited.
yes.
B, uh, even though it is audited, there are attacks like Oracle attacks and all can happen. So during the runtime also you need some solution to help you out with a real-time security. So there are multiple stages of security. Absolutely bang on. Before we take up the audience call question, sir, I request everybody, there is a poll going on. Take 30 seconds to participate. Give your this, and at the end of this session, all of you who have been attending will be getting a SecureDApp's blockchain security initiative certification. Once that is done, we'll take up questions from audience. All of you can raise your hand in case you want to speak. We can unmute you, A, B, or else we can take the questions from the chat box, sir. Anyone wants to speak and take up their questions from Mr. Venkateshan, sir? I think Mridul, can we unmute Mridul?
Hello.
Mridul, you can go ahead.
Good evening, sir. Firstly, thank you for the session. Especially the part regarding the block deletion is something that I got interested in. So, sir, I had two questions. Could you shed some light on what are the approaches we can follow for block deletions? A, and sir, if you could tell us more about the blockchain testing tool you were telling, and if we as researchers from other institutes can access it. These were
Oh,
the two queries.
oh. So thank you, Mridul. So the first one is that I was talking about deleting the blocks. So for deleting the blocks itself, we have considered the threat model. That is like, so there is network diversion attack possible. And also we cannot decide that which chain we will follow. So like that, we come up with the 3 threat models. Accordingly, we give the solution. So now the important thing is when we talk about deleting the blocks, so it varies from one application to another application. There may be applications where you need each and every transaction. So you cannot delete any of the transaction. See, one is the block header and the data part is the transaction part. So we cannot delete it. So what we are saying is there may be application where the old transactions are not required. So we can go for deleting it with some set which is predefined, so that everybody will be following. But one important thing is we have to ensure that, see, let's say you are there and I am also there and Mr. Abhishek. So we 3 are part of the network. And what we are saying, let us delete some of the block we all three are not going to delete the same number of block. So according to my storage, I will delete some block. According to your storage, you will delete some block, and similarly, Mr. Abhishek also will do. So what happened? We all are not going to delete the same number of blocks. So if I want to, in later case, if I want to fetch any one block which I have deleted, there are chances in the network that I can get that block from someone else, because he may be having that since he has more storage. And the next thing is, when let's say that that application, for example, completely we are losing the data, nobody is going to have that data or that particular block. So in that case, it is not possible for any one of us to bring that particular transaction if I need. So what we can do is, we can see that there may be the upcoming blocks. In the upcoming block, there may not be possible that it will be having more number of transactions. So in that case, we can see the older block, and if there is any if the transactions in the older blocks, that can be slowly moved to the front. But this application should be like completely, we need all the transactions in that case. If the application says that I don't want all the transactions, only some number of transactions, that the latest transaction is sufficient, we can go for the deletion. But for you, maybe in the 100th block, the latest data, and for me, maybe in the second block, my latest data is there. So in that case, that particular transaction of mine has to be moved, yours or somebody else has not to be moved. So this we can consider, and accordingly we can build our application so that even if it is deleted also, the data availability will be ensured. At the same time, the network diversion attack or other attack should not happen. So this is the first, the answer to the first question. In case of the second question I was telling about, so you can access the test bed. So maybe SecureDApp can also, they may also share that URL with you. So
We can share that, sir, with the
yes,
public group through email,
yes,
and we have
okay.
that, whatever is needed, and they all can access through that.
Yes.
We'll do that, sir. Sir, there is a question. Thanks,
Uh,
Midul. There is a question coming up, and I think that's a very apt question for you because you are into blockchain as well as into teaching. The question is, shall we implement blockchain as a course or blockchain coding as a course by default and blockchain security as a education by default in our education system? Because this decades or the decades going beyond is going to belong to blockchain. What is your perspective on that?
See, I said in the beginning, right? So we have introduced the course in 2018, and now almost like all the
No, sir,
universities.
I agree to the point that IIT Kanpur, IIIT Allahabad, there are major colleges, but
Yes.
by default, blockchain and blockchain security is not getting taught to the students as a coding skills. So that's where the
Okay.
question is coming.
Let's consider that the course can be of two category. One is the core course, which will be mandatory for every students to take, and another one is the elective.
Yeah.
So, and maybe they have the practical or not having the practical. So if they have the practical, then the coding part comes in. So in case of the core papers, see, even we know that ML, how much importance is there for AI and ML course. So that was moved as the core course recently in all the universities. But blockchain is still in the elective part, because we can say that the interested students to go for it. So at present, maybe immediately not required that the course to be moved as the core course. It can be moved to the core course for the students who are studying the cybersecurity. But if they are general in computer science and engineering, may not be immediately required for them. It will take time. And with respect to the coding, so even this time I'm teaching the blockchain course. So we say that you have to build the application. So initially they have to do certain experiments, like level DB and all we ask them to do. But at the final, we ask them, you develop an application. Because see, you are not going to develop the usable application immediately. So you develop the application so that you know how to write the smart contract or the chain code, and how you also know how to install the Ethereum or it may be the Hyperledger. So many of the students, they go for the MetaMask or they go for remix and all. But we emphasize that you also try to install Ethereum on your machine and run. Maybe you can go for command line interface and do it. So it is also like based on the credit and all. It because see, let's say if it is only theory credit, so it may not be possible to spend time for the practical part. But here in the blockchain, the concept also they should understand. At the same time, the coding is very much required. Then only the students can go and speak with confidence. If they study only the theory part, that may not be sufficient. So the coding part should be part of the course.
Sure, Professor. So, Professor, we are in last 10 minutes of our session. And there is a question I can read into chat box from Akansha Bedi. The question is, how can we do attack simulation for research purpose to prove particular blockchain is safe?
See, what happened is there are attacks that are known. Okay, these are the possible attacks that are known. So what we can do is we can write the script for those, and we need the environment. Directly, we cannot have simply the program. So we can do two types of analysis, let's say. One is the static analysis and another one is the dynamic analysis. In the static analysis, what we can do is we scan the code and see for some predefined, that is the pattern based vulnerability that are present in the code or not. So for this, we don't need any environment to run and all. Just we give the smart contract or any decentralized application code to the simulator, that is the static analysis tool, and it will say that these are the vulnerabilities that is present. But in case of the dynamic analysis, we need the environment to run that. So for example, if I am going for some web application, I need only the web server to run that. But in case of the blockchain, what happened? We need the blockchain. On top of it, I have to put the application. In addition to that, I need to have the other nodes. With only one node, I cannot go. So we need to create the simulation environment. So that's why I said that the testbed what we are having, even though we don't have at present that attack to be performed on it, but we have some script that has to be integrated. So we need some, may not be the bigger environment, at least with the 2-3 nodes. So we need to set up the simulation and then perform the attack. So there are list of attacks that are known, we can perform it. But if there are unknown vulnerabilities, in that case, it will be like, we cannot say that it will be identified immediately, because when we are going to test, we test based on whatever we know. Okay, until unless we have some mechanism with ML, like you have also a product. Okay,
Correct.
so with that, if we are going, then it may be identifying if anything new present, which is not in our database.
Correct, sir. So the product that we have, which is like we have applied for a patent, is mostly about a real-time threat detection. And this can be simulation for in terms of any code level vulnerability. They are making use of somebody's trying to get into the smart contract, trying to manipulate it at any or any unknown transaction that they are trying to do. This is going to detect it. And on top of that, there is a feature that we are coming up with in it, sir, is called auto defend. Now, it is not only going to monitor and detect and trigger. It will auto defend if there is a permission from the founder or the DApp owner saying that applying a machine learning and the pattern learning, it will detect all the outliers and you implement that auto defend feature. So all that is already live. Most of the features are already live, and we are expecting to be one among the top blockchain security company across the world in the next 5 years. Let's see how it shapes up, sir. Before that, I'll have to take up one last question. There is somebody by the name AS Phoenix, and he seems like he's a student. His question is not clear. We need to try to perceive it. What is one piece of advice you wish every student should take seriously? I believe he's talking from a blockchain perspective.
Yes, I'm reading that. Just
Yeah.
give me a minute.
Please read that,
Because
sir.
he put some 3 questions, right? Okay. So, what I can understand with all these three questions, that what should be the task that should be done at first with respect to security or building any application for going for any development.
Correct.
So it should be like uh, we should be very clear that, let's say that for any application we can go for digitization, there is no problem. We should be very clear that whether the blockchain is required for that particular application or not. Or you may prove with some model or some idea that yes, the blockchain is required for so and so purpose. So then you can go for using it. So when you are going for applying it or implementing it, so as I was telling the overhead, it is very much required that you have to convince the people that yes, the blockchain is required for this application because it has the inherent security features, and at the same time it will be giving the overhead, and we should be in position to say that this overhead is not going to be burden the application. See, there will be some cost implication there, but it won't be much. So we should consider this, and also we have to consider that what will be the threats that are possible for the application. Even we use blockchain, there are certain threats still persist. So we have to list out that, and that also we have to consider at the time of development. And when we are developing the smart contract or any decentralized application, we always consider from the base that security should also be taken into consideration. So we should not say that I develop, because normally people don't consider the security because of two reasons. One is the performance and another one is the cost involved. That should not be there, because now the scenario is changed. We definitely face the attack because there are certain group of people, they are there for only performing the attack. So that should also be considered. So these are the some basic things we have to look into building any of the applications.
Absolutely, sir. We also believe that your DApp or your product is safe as long as the hackers are not taking it seriously. It's not safe because we have coded well. We have not found a product which has been coded well and it is safe. It may be that the volume of transaction is not lucrative enough for the hackers to get into it. So there are last two questions. We'll take in two minutes. If you can take from the last, there is a question from Rajkumar Singh and then from a Tanmay Chandra Sekhar.
Okay. So that to learn blockchain coding, does it necessarily require IT or computer knowledge or other? See, when you are going to understand the complete working of the blockchain technology, because it involves various things. It uses data structure, it uses computer networks, it uses distributed systems, it uses the cryptography. So you need all those things to learn how it works. But let's say you are going to develop only application. So in that case, because you need to know only the coding, so that is sufficient. But you should see, you will be definitely getting the time. Slowly you have to build on learning that how the blockchain is implemented, how it works also, because that increase your confidence. That is very much required. And the next question is, how can a data scientist with experience in AI and ML use their knowledge for blockchain? See, when you are having the concept that knowledge on AI and ML, see, the AI and ML directly is not having the impact, but you understood AI and ML because you learned other concepts of the computer science. Okay, so with that, you can go for the blockchain also. See, the blockchain, in my opinion, it is not completely the new concept. So the pseudo anonymous Satoshi Nakamoto, he cleverly put different blocks into one, and he brought that blockchain. Even if we see the history, still people claim that such concept was there in 1970s or 80s also. But he brought it in a manner, or she or they brought it in a manner or put it in a manner, people are very much attracted on that concept and people are using it. So if you are knowing AI and ML, so that means you are already knowing multiple concepts of the computer science. So you will not be facing trouble in implementing the blockchain technology.
Correct, sir. Thank you, sir. Since this is a fixed time format, we have another 2 minutes, and I would like to take up this as an opportunity, sir. We are not taking any more questions. If there are any other questions, we can take it up on a mail and would love to professor to help them with the response and give it to them back on the email. Now, before I take up, I would like to say thank you, Dr. S. Venkateshan, for coming up, joining us today at SecureDApp's blockchain cybersecurity initiative that we have taken up. It's Bharat Security Initiative, wherein what we are planning to ensure that the digital assets, digital IP, and the data of India is protected. And for that, this is going to be a 6-week format, and we have speakers lined up every week talking about each aspect of blockchain security, cybersecurity, AI security in general over the next course of action. Uh, I would also like to say thank you to the audience for joining us, being very patient, coming up with the questions, and all of you are going to get a certification. All those who have participated in both the poll questions and have stuck towards the end of the webinar. So all of you are going to get it. It will take time, but it will trigger to your email ID. I would like to say thank you our partners, CISEC, Cybersecurity Wing of Karnataka government, managed by Indian School of Science, Bangalore. I would also like to say our partner, GeneServe Incubation from Bangalore. They all have come forward and helped us organize this. And this is something that we are doing it. We have one more partner, Center of Excellence from Hyderabad joined this our hand in making this big. So would like to say thank you to all of them. Please tune up to next week's sessions for the SecureDApp Bharat Security Initiative on 25th April at 4:30 p.m. for another conversation, interesting conversation. Thank you. Thanks a lot. Would like to wind up. Thank you, sir. Thanks a lot.
Thank you. Thank you so much for
We're
the
winding it up.
initiative.
Anything else you would like to, last line of conclusion, sir? We have 2 minutes.
So, what I can say is that the audience, or in general, I want to say, even I tell to my students also. So try to build some application so that you will learn more about the blockchain technology, how it works, what are the complexities. But don't think that developing that can be deployed as a real-time application immediately, because you have to do a lot of tests, not only the software testing part, it will also be the security test part you have to do. And very important thing is that blockchain is growing like anything, in the sense it's not only the landscape. I am talking about the new concepts getting introduced. So you can see that every week we can see some article by the founder, Ethereum founder, that some new thing is getting introduced. So we have to be continuously reading about the blockchain, otherwise we'll be missing out. So as I was mentioning, right, that we have started writing about IOTA, but after 1 year we have seen that the technique is changed. So they are keep on adding. Now most of the people are working on the zero knowledge proof or fully homomorphic encryption or verifiable delay function. Even in the case of that storage, there is one algorithm that is erasure code. So what they are saying, we don't need to store the entire blockchain. So they say that 8 KB or something is sufficient to store the block, but that will be divided and stored. So the new concepts are keep on coming, and it is very much required. We should continuously going through the concepts. So
absolutely, sir. We have to keep updating ourselves because the technology is evolving and regulation is yet to catch up. Thank
yes.
you. I would request everybody to follow and subscribe to YouTube channel of SecureDApp for the next week's session. Looking forward to meeting you all. Thank you. Thanks a lot. We can disconnect. Can someone close the call?